Alright, so we're back. This is video number 2 for e-learning day, March 18th. So at the end of the first video, I asked you guys to go ahead and solve this matrix equation. So again, remember we created this matrix equation from the systems of equations. Right? So again, we have our coefficient matrix here, we have our variable matrix, and our solution matrix. So then to solve this matrix equation, we're going to first create our inverse matrix for our coefficient. So again, we're going to use the determinant method. So here we're going to calculate the value of the determinant. Okay, remember that's right, the A times D minus the B times C. That gets us the value of the determinant. Alright, so again, this notation means inverse. Okay, so again, we're trying to find the inverse for this coefficient matrix from the equation. So that we're going to find that by taking 1 over the determinant, multiplying it by this altered matrix of the coefficient matrix. So remember, we create this by flip-flopping the AD numbers, taking the opposite of the BC numbers. Okay, so we take that altered matrix and we multiply it by this 1/2 to get us this matrix. This is the inverse matrix of the coefficient matrix. Okay, so once we done with that, we are now going to take this inverse matrix and we're going to multiply it to the left of the coefficient matrix. And since we multiplied it to the left here, okay, we're going to do the same thing on this side. We're going to multiply the solution matrix by that coefficient matrix. That solution matrix by the inverse matrix. Alright, so back to the left side, again, when we multiply the coefficient matrix times its inverse, we know that we're supposed to get this identity matrix. Now, sometimes students assume this to be true, so you might want to double check to make sure that when you do row times column multiplication of these two matrices, you do get the 1, 0, 0, 1. Alright, because if you do not, that means that your calculation of the inverse was incorrect. Alright, so you don't want to assume that this is going to be the case here. So you just might want to double check or spot check to make sure that when you do multiply these two inverses, you do get the 1, 0, 0, 1 identity matrix. Okay. Alright, so assuming that this is correct, alright, we move to the right side again. Again, we do row times column to get this matrix. So we get negative 12, 7. And again, that basically tells us that the solutions for x is negative 12. The solution for y is 7. Okay, so again, because we're solving a system of equations, that means that we write our answer as ordered pairs. Okay, so again, what we did was we solved this system of equations by setting up a matrix equation. Then we found the inverse of the coefficient matrix. Took that inverse, multiplied it to both sides of the equation. On the left side, we took that inverse, multiplied by the coefficient matrix. On the right side, we took that inverse and we multiplied it by the solution matrix. And that got us our solutions for x and y for this problem. Okay. Alright, so now when it comes to these 2 by 2 matrices. When I say 2 by 2, I'm talking about 2 equations, 2 variables, right? When we eventually get to the test for this module, right, you are expected to show all your work and do everything by hand. Again, that means you are showing all your work, how you calculated the solution for x and y. Now, I mentioned that because we are also going to give you equations that have 3 variables in them. Okay, so why don't you go ahead and write this example down. So I have 1x minus 1y plus 2z equals 3. 1x minus 1y plus z equals 1. 2x plus 1y plus 2z equals 2. Right. So last semester, right, we also solved systems of equations that had 3 variables and 3 equations in them. Okay, so when it comes to these problems on the test for this module, again, we're going to want you to solve these systems by setting up a matrix equation. Okay, so again, now we're shifting gears to a 3 equation, 3 variable system. Again, for these, we want you to set up a matrix equation as well, but this time we're going to want you to use your calculator to help you find the solution for, in this case, x, y, and z. Okay, so I'm going to demonstrate exactly what is expected and what you need to show us in terms of solving these systems. Okay, alright, so again, we're going to set it up as a matrix equation. Okay, so here it is. So here, this first matrix, that's the coefficient matrix. Right. So again, here's the coefficients for the first equation. The second row, the coefficients for the second equation. And the third row are the coefficients for the third equation. Right. Here's our variable matrix. Again, we got 3 variables this time, so I get x, y, z written as a column. And then that equals our solution matrix, right? The answers to each equation written as one column. Alright, so again, we're going to be using our calculator to help us with this one. So, to get us ready for that, okay, so we need to, again, right, write out what we would do to find a solution for this matrix equation. So remember, we're going to get the inverse for this coefficient matrix. Now, we cannot use the determinant method or the systems method to find this inverse, right? We're going to have to use our calculators. So, what we're going to do to prepare us for that is that we are going to write the notation for the inverse. Right, so we're taking this coefficient matrix and we want its inverse. So again, instead of actually finding the inverse, we are just going to put this -1 notation here, denoting that, okay, this right here is the inverse matrix for the coefficient matrix. Okay, so this is the inverse matrix for that coefficient matrix. Note that you do not actually have to find this inverse matrix. Just say, okay, here it is as a notation. So we're going to multiply that by the coefficient matrix. So I'm just going to copy that over, and that's just the coefficient matrix. I'm going to multiply that by our variable matrix, x, y, z. So that's the left side of the equation. On the right side, then we're going to take this solution matrix and we're going to multiply it by the inverse matrix. So again, all you have to do is just write it as a notation. Right? So there's the inverse matrix, and we're going to multiply it by the solution matrix. Okay, so now all of this is just the setup. You do not actually have to do any of the calculations by hand. I'm now going to show you how you're going to do this in your calculator. Okay. So now know that, again, this side of the equation, right, when we multiply a matrix times its inverse, right, we're always going to get an identity matrix. Right, and someone in class asked last week, okay, so what is the identity matrix for a 3 by 3? Well, it's going to look like this. Right? That's what that turns out to be. So again, you don't necessarily have to remember that, right, but just again know that that's what's going to be. We're not actually calculating this, right? We know that when we multiply matrix times its inverse, we get this identity matrix. Right? So again, I'm just going to bring down this variable matrix, x, y, z, equals. Alright, so now this part we're actually going to do in our calculator. Alright, so that's going to be definitely done in our calculator. So let's go ahead and take out your graphing calculator. I'm going to show you how we're going to do this in our calculator. Alright. Alright, so to do a matrix, we are going to find the matrix button, which again is in blue underneath the math button right here. So you're going to have to press second. And this x minus 1 button to get to here. Alright, so again, here's our matrices. So we need to create these matrices. So you're going to arrow over to edit, and you're going to create a matrices. Now, if you don't have these right here, then you can easily create them. All right, so I'm going to go ahead and edit matrix A. So here I can change the dimensions, right? So first we want to change the dimensions. So if yours doesn't say 3 by 3, all you got to do is like type 3, right? Arrow over 3, and then arrow down. Right? So that's how you can change the dimensions of that matrix. And once you do that, all you have to do is enter in all the the elements for this matrix. All right, so go 1, enter, -1, enter, 2, enter. Right, just type in a number, press enter. It will bring you to the next spot in the matrix. Okay. So once you're done with that, you're going to press second matrix again to bring you back to here. So now we want to create this matrix. Right, so again, you're going to arrow over to edit. Anytime you want to create a matrix, you have to go to the edit part, press enter. Again, if this is not 3 by 1, then you can change it. Right? Then when you change it, once you change the dimensions, then you can start entering in all your elements. Okay, so now we've created both of these matrices. Alright, so the last part is goes like this. Alright, so we are going to go back to this screen. Now instead of edit, we're just going to go ahead and just press enter. So I want that 3 by 3 matrix first. So I'm going to press enter. So this pops up on my screen. Alright, but we want to get this inverse symbol. Alright, so I want the inverse of this matrix, so I'm going to see where that x to -1 right here. We're going to press enter, or press that button. Right. So there's the inverse matrix. We're going to press times because we want to multiply, and we want to go back to matrix. So it's second, and then this button. All right, and then I want option 2. There's that matrix, and we press enter, and there's our answer matrix. So write that down, and there's our solution for x, y, and z. Alright, again, when we're done, go to that worksheet, and do those problems. If you have any questions, let me know. All right, have a great day.